the mole. So mole means different things to different people. To a biologist, what's a mole?
An animal.
Little animal, right? Poor eyesight, burrows underground, makes a mess of your yard, right? What's mole? It's a Mexican sauce, right? Like guacamole is my favorite. So those are not what we're talking about. When a chemist says mole, it's a unit of measure. This is the chemist's dozen. So Avogadro's number is like the 12. In 1 dozen equals 12 things. Mole is the name of that unit. 1 mole is Avogadro's number of things. And just like dozen can apply to cars or people or universes, mole can apply to anything. A mole of atoms, a mole of molecules, a mole of stars, a mole of peanuts, whatever. So 1 mole is equal to Avogadro's number of particles, of things, of pieces, okay? Here is a picture of a balloon. That balloon, I think that's oxygen, that balloon contains 1 mole of oxygen. Just a regular balloon. So, reasonable amount of stuff, right? This little graduated cylinder here contains 1 mole of water. Small, manageable, but yet visible and handleable, is that a word? I just made it up. Size of stuff. Here's a watch glass with 1 mole of sodium chloride on it, just to give you an idea of how much a mole is. Bless you. So the mole relationship allows us to convert between number of particles and mass of substance. Just like we can convert between dozens of eggs and number of eggs, we can use this to convert between moles of particles and the number of particles, but also between the number of particles and the mass of a substance because of how it's defined. So calculate the number of molecules in 0.0763 moles of chlorine gas. I forgot to tell you something, or point something out. So mole is spelled M-O-L-E. The abbreviation for mole is MOL. I don't know why they felt this needed an abbreviation, but it gets used a lot. I mean, the E is silent, I'll give you that, but what about the word molecule? That's a much longer word. That doesn't have an abbreviation. We have to write that out every single time. Again, they didn't consult me when they made these things up. But let's calculate the number of molecules in, there's the abbreviation, 0.0763 moles, MOL, of chlorine gas. We've learned that chlorine gas is a diatomic element, and so the individual particles are molecules and not individual atoms. So we're going to use dimensional analysis again when we do this sort of thing. So we've got, maybe I should pull out my pen here. There we go, 0.0763 moles of Cl2. And we want number of molecules. So we want number of molecules. And then to get this mole unit to go away, we're going to put that down here. And this is dimensional analysis with some different units. The relationship between mole and number of molecules is Avogadro's number. 1 mole equals Avogadro's number of particles. In this example, the particle is a molecule. So in our conversion factor here, where do we put Avogadro's number? On the top, because mole is the chemist's dozen. 1 dozen is 12 things. It's not 12 moles equals 1 egg. 12 dozen equals 1 egg, right? So 6.02 times 10 to the 23rd. And it always ends up being the long number with the long word. And then down here, 1. Now, you need to be able to do scientific notation on your calculator. because I have not yet seen a calculator that can handle Avogadro's number in decimal form. And do you really want to count 23 zeros as you punch all those in? I don't think so. So this is 0.0763 times 6.02, and then you should either have an EE or an EXP button. So I'll just call it EE because that's what mine is. 6.02 EE 23, and then we get an answer. Using significant figures, both of these numbers have 3 sig figs, and so I'm going to come up with 4.59 times 10 to the 22 molecules. Any questions? I want you to get your calculator out and actually do the calculations as we're going through class today. And if your calculator is not cooperating, please come and see me at the end of class and I'll talk to it for you. Because it's your calculator's fault, isn't it? It's not your fault. I'm the calculator whisperer. I can get your calculator to cooperate with you. So let's do this one. Calculate the number of moles of copper in 5.34 times 10 to the 25th atoms of copper. So in a way, these problems are nice because there's only one number that's given, and so that has to be the one you start with, right? So I write down that 5.34 times 10 to the 25th atoms, and they want moles. So I'm going to multiply by moles and divide by atoms. It's the beauty of dimensional analysis or unit analysis. The units tell you whether you're multiplying or dividing, and you don't need to remember that. Then we look at this conversion factor. We've got mole on top and atoms on the bottom. This is the relationship between moles and number of particles. What's the name of the particle in this second example? Atoms. So I want to put Avogadro's number with the particle, and the 1 goes with the mole. So I've got 5.34. Yeah, I put my iPad down on it. That was lovely. Okay, we're back? Good. I'll have to avoid doing that again. 5.34 EE 25 divided by 6.02 EE 23 equals, and this comes out to be 88.7. moles of copper. I should have put a box around this one too. Any questions? Yes?
On the homework, is he going to have it just put moles, or is he going to have to spell it out all the way? Will it not be necessary?
It should accept either if it's asking you for the unit. Master in Chemistry should accept either MOL or MOLES. More frequently, it has the unit written there for you, and you just need to type in the number. But they're interchangeable. Any other questions?